Hello everybody. This is our second lecture on Fourier series. In the first lecture, we have seen the periodic functions. We defined the periodic functions and then we defined the Fourier series of periodic functions. Then we obtained the Euler's formulae. So in continuation to that, today we are going to see the Fourier series of even and odd functions. So let us start. Even and odd functions. Let f of x be any function then if f of minus x equals to minus of f of x for all x, then we say that f of x is an odd function. Similarly, if f of minus x equals to f of x for all x, then we say that f is an even function of x. Okay, now we will see some properties of even and odd functions. First of all, note this: if f is even and g is an odd function, then their product is an odd function. That means product of even and odd function is an odd function. If f is even and g is even also, both are even, then their product is an even function. Then their product is an even function. That means product of two even functions is an even function. And lastly, if f is odd and g is also odd function, then their product is an even function. Means product of two odd functions is an even function. Also, integration about this even and odd functions. If f of x is an even function, then we have integral minus L to plus L f of x dx equals to 2 times integral 0 to L f of x into dx. I repeat, if f is an even function, then the integral from L to plus L f of x dx is 2 times integral 0 to L f of x dx. Similarly, if f of x is an odd function, then this definite integral minus L to plus L f of x dx is equals to 0. So these are two important properties. So with this much knowledge, now we are going to define the Fourier series of even and odd functions. So let us see. We know that if f of x is a periodic function of period 2L defined in some interval c to c plus 2L, then the Fourier series of f of x is given by f of x equals to a0 by 2 plus summation n varies from 1 to infinity an cos n pi x upon n plus summation n varies from 1 to infinity pn sin n pi x upon n, where this a0 is obtained as 1 upon L integral c to c plus 2L f of x dx. An is given by 1 upon L integral c to c plus 2L f of x cos n pi x upon L into dx, and Bn is given by 1 upon L integral c to c plus 2L f of x into sine of n pi x upon L into dx. Then there we have seen different four cases. The first case c is 0, so the interval of definition is 0 to 2L. In second case c equals to minus L, so that the definition of interval is minus L to plus L. The next case that we have seen, L equals to pi, that is the period of the function is 2 pi, and c equals to 0, so the interval is 0 to 2 pi. And last case where L is pi, that is period is 2 pi, c is minus pi, so interval of function f of x is minus pi to 2 plus pi. So these four cases that we have seen. In that cases, how to write the Fourier series and how to obtain this a0, an and bn, that we have seen. Now suppose the interval of definition of f of x is minus L to plus L. That means the function f of x is a periodic function with period 2L. Then what happens? The Fourier series is of f of x is, as usual, it is given by a0 by 2 plus summation an cos n pi x upon L plus summation bn sin n pi x upon L. Okay. Here, when we calculate the case 1 we are going to discuss here is f of x is even function. Suppose f of x is an even function. What happens when f of x is an even function? If I calculate a0, it is 1 upon L integral minus L to plus L f of x dx. As we know the properties of even function, if f of integrand is an even function, then the integration from minus L to plus L f of x dx will be 2 times integral 0 to L f of x dx. So this is equals to 2 upon L integral 0 to L f of x dx. So a0 now in this case where f of x is even is 2 upon L integral 0 to L f of x dx. Okay. Similarly, an is 1 upon L integral minus L to plus L f of x into cos n pi x upon L into dx. Now we know that f of x is even function, cos of n pi x upon L is also an even function, and we know the properties of even functions. The product of two even functions is again a even function. Therefore, this integrand is an even function, and when the integration of a even function from minus L to plus L, it becomes 2 times integral 0 to L. So this is also equals to 2 upon L integral 0 to L f of x cos n pi x upon L into dx. And then what about this Bn? Bn equal to 1 upon L integral minus L to plus L f of x sin n pi x upon L into dx. Now see, f of x is an even function, sin n pi x upon L is an odd function, and the property says that the product of even and odd function is an odd function. Whenever the integration of odd function within the limit minus L to L, we take the value of that integral comes to be 0. Therefore, in this case, since the integrand is an odd function, the integral from minus L to L f of x sin n pi x upon L dx will be 0. So Bn is 0. Okay. So what we see here, when the function f is an even function, if f of x is even, then a0 is 2 upon L integral 0 to L f of x dx. An is 2 upon L integral 0 to L f of x cos n pi x upon L into dx, and Bn is 0. And therefore, when the function f is even, in that case, the Fourier series we obtain is like this: f of x equals to a0 by 2 plus summation n varies from 1 to infinity an cos n pi x upon L. Okay. So this is the Fourier series of even function, where this a0 and an are calculated using this formula. This is a0 and this is an. So this is the case where f of x is even. Now we'll see another case where f of x is an odd function. Let case number 2, f of x is an odd function. What happens if f of x is an odd function? a0 is again 1 upon L integral minus L to plus L f of x dx. And as we know that integral of odd function within the limit minus L to plus L f of x dx is 0, the value of this integral will be 0 in this case. So a0 equals to 0. Again, an, it is 1 upon L integral minus L to plus L f of x cos n pi x upon L into dx. Here we see that f of x is odd and cos n pi x upon L is an even function. And product of odd and even function is an odd function. Therefore, this is the integration of an odd function. And within the limit minus L to plus L, it is always 0. So the value of this an is also becomes 0. So an is also 0. Then what about this bn? Bn is given by 1 upon L integral minus L to plus L f of x sin n pi x upon L dx. This f of x is an odd function, sin n pi x upon L is also odd function. The product of two odd functions is always an even function. Therefore, this is the integration of an even function, and it comes to be 2 times integral minus L to 2 times integral 0 to L f of x sin n pi x upon L into dx. That is 2 upon L integral 0 to L f of x sin n pi x upon L. So Bn equals to this 2 upon L integral 0 to L f of x sin n pi x upon L. Okay, so this is value 1, this is another value, and this is third value Bn. Therefore, when we conclude that when f of x is an odd function, the Fourier series is given by f of x equals to summation n varies from 1 to infinity bn sin n pi x upon L. Okay. So this is the Fourier series of even and odd function. Now, if you consider the interval minus pi to plus pi, if we consider the interval minus pi to plus pi and f of x is even, so obviously I will consider this is case 3 where L equals to pi, interval is minus pi to plus pi, f of x is even, is an even function. In this case, Fourier series as f of x is an even function is given by a0 by 2 plus summation an cos n pi x upon pi, means cos nx, n varies from 1 to infinity, where this a0 is given by 2 upon pi integral 0 to pi f of x dx. Okay, and an is given by 2 upon pi integral 0 to pi f of x into cos nx dx. So this is the case where f of x is an even function and the interval is minus pi to plus pi. Now, if f of x is odd and interval is minus pi to plus pi, in that case, since f of x is an odd function, Fourier series of f of x is given by Bn is given by Bn equals to 1 upon pi integral minus pi to plus pi f of x into sin n pi x upon n is nx into dx. Now f of x is odd, sin nx is also odd, therefore product of two odd functions is an even function. Therefore the value of this integral will be 2 times. So 2 upon pi integral 0 to pi f of x sin nx into dx, and hence the Fourier series of function f of x in the interval minus pi to pi is given by summation bn sin nx. N varies from 1 to infinity, and this bn is 2 upon pi integral 0 to pi f of x sin then x. Okay. So this is all about the Fourier series of even and odd functions. Okay.